Welcome to another Maths with Paddy video. This is where, we always talk about a theorem from mathematics or a nice idea. We do an example and we always try to get it done in 5 minutes. So today I'm going to talk about polynomials and their continuity. So there's one result. So this theorem is that all polynomials are continuous functions. So all polynomials are continuous functions. So this is quite easily proved. Okay, so proof. Sorry. So the proof is simply, you can just simply say that the limit, right, for our polynomial f of x, as x approaches c, this will be equal to the f of c. Okay? So on the basis of this, you can say that all polynomials are continuous. And this is because they adhere to the three properties um, of continuity. So one property, we did this in the video, is that the f of c exists, which it does. The second property is that the limit of f of x as x approaches c exists, which it does. And the third requirement for continuity is that the limit of f of x is equal to the f of c. So we saw earlier when we get the limit of f of x as x approaches c for a polynomial, it's just a polynomial evaluated at f of c. So that allows us to write this statement. It corresponds to the third property of continuity, and therefore we know that polynomials are continuous. Okay, so I also want to talk about, I'm just going to give a statement. So this is in relation to basically just a few rules for continuity of functions. Okay, so if we have, if f and g, okay, are continuous, two continuous functions. I'm just going to give a statement of like some of the algebra. So like, if we have two continuous functions f and g, if we add the functions f and g, okay, the resulting function will also be continuous at c, okay? And secondly, we have subtraction. So if we subtract two continuous functions that are continuous, I should say these are continuous at c, because we always have a continuity at a particular x value. So the subtraction of two continuous functions is also a continuous function at c. Thirdly, we can consider a product. So a product, f by g, is also going to be continuous at c. Okay. And then fourthly, we can also get into division. So we're looking at a quotient function. So the quotient function will be f over g, okay, and this will also be continuous at c, okay. It's going to be continuous at c, but this is where we always have to think about division by zero, okay. So division by zero, we have to watch for that, okay. So the division, the denominator, g of c can't be equal to zero. Okay, if this function is to be continuous at c, the denominator can't be equal to zero. But when we're dealing with quotient functions, they will also be discontinuous at values where the denominator is zero. So this is a statement. Okay, so this is going to be and discontinuous at c when, okay, the denominator g of c is equal to zero. So there will always be some discontinuity when the denominator is zero. Okay, so we can do an example. Example is where is the following function. So we're going to look at a quotient function, h of x, and this will be equal to x squared minus 9 all over x squared minus 5x plus 6. All over x squared minus 5x plus 6. Okay, so basically we can think about, with one polynomial over another. Okay, so if we think about the polynomials, x squared minus 9 and x squared minus 5x plus 6. Okay, these are continuous everywhere since they are polynomials. Okay, so these are CTS. So just examining the upper polynomial and the lower polynomial. Okay, so they are continuous everywhere. They're continuous everywhere. Okay, since everywhere, since they are polynomials. Since they are polynomials. Okay, so so h of x, our function, is not continuous when the denominator is equal to 0. So let's just work that out. H of x is not continuous, not CTS, when okay, the denominator g of x equals 0. I dot e, okay, when x squared minus 5x plus 6 is equal to 0, okay, and essentially that is I dot e, let's get another slide, okay. So essentially we just take that x squared minus 5x plus 6 and factorize it, okay, so if we factorize it, we'll get x minus 2, and we'll get x minus 3 is equal to 0. Okay, so uh, so basically, from this we can find out the x values that correspond to the denominator equal to 0, and that corresponds. So I dot e when when x is equal to 2 and x is equal to 3. Okay, so these are the roots of the polynomial in the denominator, okay? And x is equal to 3. So when x is equal to 2 and when x is equal to 3, that will make the denominator equal to 0, and that will have the resulting discontinuity. Okay, so thanks for a million. See you next time. And click like and subscribe if you like.